Hi everyone, welcome to the 345 podcasts, and today we are going to talk about how AI is improving quality control in manufacturing. I'm Andrew from 345 and I'm with my colleague Danny. Hello.
Oh yeah, how you doing?
Well, fantastic. It's Friday,
Yes.
and and it's a bank holiday weekend, so looking forward to all that. Uh, Danny, and I know that this is a topic that you're particularly interested in. So what's a good example to start with of how or what sort of areas are we looking at when we talk about how AI is improving quality in manufacturing?
So obviously we speak about this on a regular basis, and like you say, I'm fascinated by this stuff, and I'm fascinated by how some of the bigger manufacturers now are using AI for quality control, and I think a really good start would be something like, in terms of a manufacturer that I know is using this stuff already, is someone like Walker's, for example, who are using this to not only quality control their products to make sure that they're getting the right product out there, but it's also saving money as well, because they're not having to waste these products later down the production line.
Yeah, because
Um,
one of the things with quality is the earlier in the cycle you fix your quality issues, the cheaper it is.
yeah,
Because if you make something faulty, by the time you've shipped it and it's gone to your customer and you have to fix it then, that's really expensive. Whereas if you can find that faulty thing just before you've even made the product.
mm,
So one of the things is to, so it's almost like the biggest bang for buck is just not letting faulty stuff get in the front door, isn't it? Just
that's it. Yeah, it's
so
it's
what would be a good example of that?
So if we said, let's take Walkers as an example, because I think it's a really good example, and
Yeah,
because of the fact that they are a global organization. So obviously we all know Walker's crisps, um, and obviously the very beginning of that production line is a potato,
yeah,
or
sacks and sacks. Well,
sacks of spuds.
containers, lorry loads of
Yeah,
potatoes going in the front end.
absolutely. And what I find, or what is really important with those spuds is obviously you've got the growers, and you've got different types of growers across whether you're in the UK or wherever they're being grown. Um, it's all about having the right spud for the right job.
Yeah,
And if you're getting potatoes coming through production line that are potentially, let's say they're green potatoes, for
yeah, because
example.
potatoes are a natural product, so there's naturally going to be variations in them, but and some of them are going to be defective. And green
Yeah.
is a typical one, green potatoes, but also they can be black because they're a bit rotten, or they can have blight on them. So, but there's all sorts of things that they can be wrong with them.
That's it, yeah, and we've all had that packet of crisps that have had that horrible green crisp in there that you end up just throwing
When you
away.
get the green crisp, you like hold the green bit and then try and nibble all the rest of
Just
it.
get the rest of it out, yeah.
Giving all the rest of the good crisp, and it's like, oh, there's like it.
Especially if it's prawn cocktail, but let's not get into flavors.
Oh, see, um, cheese and onion, classic.
Oh, classic, the nation's favorite. Um, so what I think is, in terms of quality control and how AI has adapted and also has really pushed itself into this space, is um, picking up these. I was going to say bad apples then, but that's a different
But that's for the
conversation.
cider makers, yeah.
That's for the cider makers, yeah. So picking up the bad potato at a,
Yeah.
at a very early stage, and I'm talking the very beginning of the
Yeah,
production
so,
line.
so so basically these come in on a lorry, they get loaded on a conveyor belt, and it's really that, and before they even go into the machine to be processed, it's on that conveyor belt that we're kind of talking about, isn't it?
Yeah.
That you're right at the very very start of the process. And these things are trundling along in a conveyor belt, and what might happen then?
So what would probably happen if we look at, let's say before the world of technology came into play, you'd have a human in there looking
Yeah.
through the product.
Or sometimes
Um,
you might have on a something like that, you might have like 20 or 30 people literally just on each side of a conveyor belt.
Yeah.
I did have a job once putting carrots on a conveyor belt when I was
Oh, really?
a student. I had a summer holiday job putting carrots on a conveyor belt, and I know what these factories are like.
Wow. There you go. So
and
you've seen it
I,
firsthand then.
I've seen it firsthand.
Yeah. And I think this is where I think you can human error comes into play, and that's where potentially human error can also cost, especially I don't even think it even matters how big your organization is. If you're doing something like this with fruit, veg, anything like that, a human error halfway down the production line can become quite costly, because you're then throwing product away that's maybe, let's say we've missed that out. So let's say we've completely missed a whole bunch of these products. They've gone halfway through the production line. They've used power and energy to obviously chop, and even more importantly cook, which
Yeah,
again we can
that's
talk
the big
about.
energy input, isn't it?
Yeah, so we can start talking. I mean, we could probably not in this episode of the podcast, but we could even talk about
Maybe
energy
next
expenditure.
maybe next
Yeah,
week on that one.
yeah, with energy expenditure and things like that. So, that's been a cost element, but to then have to throw that product away because it's not, because you're doing quality control at the end rather than at the start. And I think
Yeah.
that's where we start to find that, you know, because of the size of the organization, and because of the amount of product that's going through, it is so difficult for a human to actually pick those things out and actually try and get every one.
And
Whereas,
but one of the other things though, and I think this is a kind of really important thing as well, that I mean, we've talked a lot in the past about kind of the way we do software engineering, and we use Devops to take what we call the toil. We take the toil out of that, because humans are really good at the creative stuff and imagining new things and that sort of thing. What it's not the best use of human effort to do tedious conveyor belt stuff. That's the stuff that machines are really good at. The stuff where you got to do the same thing 1,000 times a day.
yes,
It's that's kind of as humans that's not really what we enjoy, and it's not what we're best served for. So also we're kind of taking the toil out of that as well. So we're actually doing. So it's both the fact that machines can perhaps do that more reliably, but also it's the fact that it's sparing someone from having to do a mind-numbingly tedious job as well.
yeah, no, that's a really good point. So I think the next point I'd like to ask you is in and around the, how does this work? We've sort of seen how we'd like it to work, and we've seen why we want it to work really well. Let's sort of touch base on how it works, and what are the mechanisms as to how we get it to be, let's
Yeah,
say, trained.
how it all fits together.
Yeah,
So
let's yeah.
I mean, so obviously, yeah, if you look at a human, the main things you've got are you've got eyes, you've got a brain, you've got hands, and effectively what we'd be doing on an AI situation with that is we'd be replicating those things. So instead of eyes, obviously you've got a video camera, and you've got a video camera on top of the conveyor belt looking at this stuff. And then the hands, obviously you'd have something robotic where a control system would say there's a potato there's a potato at this place, pick it up and chuck it out. And you'd have a robotic arm, that very these things are lightning fast, but they're just to pick stuff up and get rid of them. So but those robotic arms, that they need a control signal to say where the potato is that they're going to get rid of, and that's where the brain thing comes in. The brain is obviously the AI. So you've got an AI model, and the AI model would be taking in the video signal, or it may take in a video signal, or it may take in, because video ultimately is a series of pictures. So you might actually be analyzing them as a photograph rather than as necessarily as a video. But it's so let's say it's processing an image, and it looks at that image, and then and it needs to be able to determine what's a good potato, what's a bad potato, and which bits are irrelevant. And that all comes down, as with all these things in AI, a lot of it comes down to data. So you have to train it, and what that involves is really massive amounts of footage where you're picking out the potatoes that are done. And what you might be able to do is you might be able to actually video, if you've got humans working on the production line, you might actually be able to video them picking the potatoes out and actually use that as examples to sort of say that, so the ones that have been picked out, those are the ones that are obviously bad. Otherwise, you've just got to manually create a data set. And these sort of data sets, I mean, especially for something like potatoes, because they come in different shapes and sizes, and there's different colors, and there's different, and what happens if they're slightly upside down, and there's you need a lot of you need to feed that with a lot of test cases, and a lot of data. So the best way to do it would be to observe the factory in action and use and be able to consume that data. Alternatively, you've got to manually put that data set together, or semi-manually by literally taking loads of photos, thousands and thousands of photos, and marking them up on the computer as to which ones you've got to get rid of. And then you put that through an AI model to say, to sort of say, here's a photo of a bunch of potatoes on conveyor belt. These ones are the ones you're going to reject. And then just and then you're back into that normal machine learning training thing. But you've got your training data, your testing data. You've got your experiments, and the thing that pops out is a model at the end. Those are the kind of the main components that make that sort of thing work.
Okay. So can you just so this is just more for my own interest actually. Can you work it the other way when it comes to training the data, and work it where so you can work it where you're actually, rather than removing the bad spud, you're actually keeping the good. So you actually train. Yeah.
So I mean, you could do, and effectively what you'd want is the model to be saying good and bad. So the first thing you do is you say, where are the potatoes? And you get a list of all the potatoes, and then you say, okay, for each one of these potatoes, is this one good or bad? And so you might almost have like two stages to it. So you'd have a potato identification model, maybe, and then you might have a potato good or bad model that actually takes each one of those and says whether it's good or bad. And then you've got the option to either, like you say, you can either pick out the good ones or you can pick out the bad ones, but that just depends on how you're going to optimize the process. What normally it's on something like this, you're getting rid of the bad ones because all the good stuff's just going through on the conveyor belt. So that's kind of a really good example then of stopping bad product getting in. But then there's also particularly if you're if that manufacturing process is complicated or whatever, you things can go wrong during the actual manufacture. So you need to check product that's coming out. So what are some ways that you've seen of that happening?
So one thing that I have seen actually recently is a project where with manufacturing again is tins of beans, so cans.
Tins of beans. Everyone loves beans,
cans. Yeah. So obviously a can with as we know, canned food is meant to last. But a damaged can could obviously affect the product that's inside it.
Because the coating is somewhere where you can get corrosion in the metal, and then it doesn't last, that sort of thing. So
that's it. Yeah. So
you should never buy a dented can.
Well, no, that's right. You should never buy. So listeners, here's a tip for this weekend: never buy a dented can.
Because they can become contaminated.
Yeah, because they can become contaminated. Unless it's a can of beer, I'm pretty sure that's okay. yeah. So
they're aluminium
there you go. So
rather than steel, so that might be the difference there.
So establishing a damaged product coming out the back of the production line is something that is really interesting as well, because it just means that there's obviously, if we're doing some things really well at the start, but there's still things coming out at the back end. There's obviously something in the middle, and what are the processes in the middle that are potentially failing, that are leaving us with a damaged product.
Yeah, and there are always things that happen. I mean, let's just stay on the tin can thing for a second, because you get a tin can, you put a lid there, and you've got like a tube, and you've got a lid on the bottom, and then you've got something on the top, and it seals it. But sometimes these things can be slightly out of place. Sometimes the thing can be, it's just the way it happens. It's just random, the randomness of physics. Sometimes things are in the wrong place, they get knocked, and then there's a slight defect. But again, I mean, when you're trying to detect whether a can is faulty or not, I mean, would that be video again, or photos?
You could use that. You could also look at weight. There could be a small distribution in weight that's been moved. I think that could also, still using an AI.
Yeah. So for machines that are dishing out quantity of stuff, so whether that be nuts and bolts in a packet that's going to go and be sold at B&Q, or whether it's like you say liquids, or whether it's rice in bags of rice. Mm-hmm. Those need to be within margin of error. But the thing is that these sort of things, just measuring the weight is something that you can do by a normal control system, because you can weigh it. But but for a normal control system to detect a dent is really, really hard. There's another example actually, that because I used to work I used to work in manufacturing years ago in aerospace, and the company I worked for, we made aircraft equipment. So all sorts of things. I mean, the most famous thing was they made the nozzle swivelly things for Harrier jump jets, and those things, they come in the body of them is like a big casting, and when you get a casting, it's obviously it's done in sand or whatever, and it comes in, and then you have to machine the faces off so it can all be, drill holes in it so it can all be bolted together. But castings are notorious for having potential defects in them, because it can be a less than ideal process from the point of view of consistency. And one of the things you get is like microscopic cracks. And so they do so one of the things they do in it is dye penetration testing, where you dip it in dye. And if you've got a crack, that dye will penetrate into the crack, and then you put it under like ultraviolet light, and all the cracks like fluoresce. But it's kind of a very
amazing.
But it's a very kind of manual process, because you've got to have some, dipping it in dye, taking it out, and putting it under a light. You can get that can be done in the production line. But then it's having the guy there with the magnifying glass that's the the kind of the labor intensive part of it.
Yeah.
But that's the sort of thing again where you can get you can put that in front of a camera, rotate the part in different angles, take photos of it, and you can use you can train AI to be looking for those defects where the dye is penetrated into cracks, and that would save a massive amount of time as well, just doing that, because that can be a really that can be a labor intensive thing. And if you can just automate that, you've got another thing there that just makes sure you've got the quality in the process all the way through. And especially that, I mean, that's really high value stuff as well. I mean, if you don't catch that and you let that stuff get on an aircraft and it fails, I mean, it's bad things happen.
Yes.
So
catastrophic errors.
So you got to catch this stuff, and at the moment it's traditionally it's a really labor intensive process, but actually it's something that you can train AI to automate. And the same thing that you're getting sample pictures and training a model to look for the fluorescent bits of dye in that show that there's a crack there, and then just say this part's bad, this part's bad, this part's good, this part's good. So those are so we've taken in a factory we've tried to improve the quality by making sure that any defective raw material gets caught in an early stage. We're also kind of taking the stuff at the end of either a component or a finished product to say, that making sure we've got quality gates there. And then there's also the bit in the middle of the actual process that's happening. So it's the quality control of that process and making sure that everything's okay. And there's some really interesting stuff going on there. So I know of some projects where, for example, in electronics manufacture, where when they do soldering, for example, and it's a similar thing with welding, that you can kind of use a camera and analyze a circuit board, and you might be able to spot something that's going wrong, but actually sound is as good an indicator as the visuals, because the sound of a weld or the sound of a solder is as much of a giveaway on quality. So what you're trying to do is, so if you're monitoring that, and you can just, so first of all, you can detect when bad things have happened, but it may also be that you use that as part of your control system to say, okay, maybe we've got the wrong temperature, maybe we've got the wrong, the wrong blend of materials or something like that. So that's and again, it's AI and it's data and it's that sort of thing in training a model, but if we look at like how sophisticated AI models are, a model that just takes a bunch of numbers and does a statistical analysis on it, they're relatively simple. Then photo kind of processing is another layer of complexity. That's much more difficult to do. But then sound analytics is like another layer. It's like another level again. It's actually that's actually quite hard because because you've got to be because you're processing the whole kind of sound wave over a sequence of time to do that, and that's okay. This problem's been solved, but it is a much different level of complexity.
I suppose as an example for people that are listening, if you looked at the same drum getting hit multiple times, if it gets hit in different places, it's going to make a different sound, but it's the same drum. And I think that's where you start to come into play of that training.
And that's it. And when you're bashing lids on cans of beans, how the sound of a good lid going on will be different from one that's slightly misplaced. And so you've got this, and so you've got all sorts, so we've got various tools in our arsenal here for actually monitoring quality. I mean, the other thing is laser measurement of things, and you can put laser measurement on stuff and just have an idea of whether things are the right size. So that's that's kind of but it's also where those things, where machine learning takes it to another level is not just that you're measuring stuff, but it's that over the course of the day you're measuring, you're making widgets on the production line. You make 10,000 widgets a day, and they all get measured, and over the day they're all going to have variations in them, and it's like, well, okay, but then you start to look at, well, what happens, is it the same every day of the week? Is it the same? How does it vary by time of day? What happens if it's a hot day? What happens if it's a cold day? What happens if it's a humid day? What happens if it's if we've got metal that's bought from one place versus being bought from the other? And you can start to look, and that's one of the things that we do with data is it's not just looking at one data set, because typically if you're looking at one data set, often statistical methods can do that, but it's when you're looking at, so when you're trying to combine many different complex data sets, and then to see whether there's anything in that, and that's, I think, quite an exciting part of process control, and just looking at how you can use that sort of thing
Yeah.
use those multiple data sets together to sort of say, actually, on a Tuesday when it's sunny, things go wrong.
Mm.
And then then you can either find out, dig more into why that is, or put measures in place to control that out of the system.
And that's it. It's about analyzing it and using that data to move yourself forward as a
Yeah,
business, I guess. Which
because
is
if you don't
ideal.
take action on it, if nothing changes, what's the point?
Yeah.
Because it's all about taking action, isn't it? It's all about, you know, because we have our data maturity model, which is like receiving, capture, taking the data in, then store and categorize, where you're kind of cleansing it and making sure it's what it is.
Hmm.
Then you've got the analyze and predict part, which a lot of this falls into. But
Yeah.
we always have like the last phase is decide and act, because if you don't make decisions and you don't take actions, then what's the point?
And I think that's where a lot of businesses sort of miss that part out. They sort of get to,
We've got to the isn't this interesting part?
yeah, this is really interesting, and I love looking at all this data, and then it's sort of like, right, okay, well, great, we've got all this data, and this is all brilliant, but actually, we need to now act upon it, and that's where that's why we love doing what we do, because we love to see outcomes,
Yeah,
and that's really important to us.
yeah. It's
Seeing,
all about the difference we make to the world, isn't it?
yeah, making a difference, and seeing a business that we've worked with, that we've obviously gone through all this data, we've given them um, given them results, and then they've changed something within their organization that's made a huge difference. That's what we love to see, and that's what we like being part of. So
Yeah,
yes, make sure you're acting upon your analyzations and
or or
analyzing,
or, or at least deciding.
or at least
Right.
deciding. Yeah.
Okay. So I think we're going to wrap up there, and next week we'll look a bit more at some of the other aspects of manufacturing and AI, because obviously we looked at quality control, but there's a lot of other things. There's a lot of other things, and we touched on the cooking. So we'll talk about how AI affects the cooking of crisps in next week's episode.
Yes. Yeah.
All
This
right.
is this is a big one. This is a big one. I'm looking forward to that, actually, because that part is going to be important from a cost, like you say, energy expenditure. So yeah, looking forward to chatting about that next week.
Cool.
Perfect.
All right. Thanks for listening, everyone. And from me and Danny, we'll catch you soon. All right. Bye now.
Take care. Bye bye.